Assalamualaikum and good morning. So today we will proceed to chapter 5. Chapter 5 is about state of matter. So in this topic we will have 4 subtopics. So the first subtopic is about gas, second one is liquid, the third one solid, and the last one the new subtopic for you known as phase diagram. So for 5.1 gas, we are going to explain the basic assumption about kinetic molecular theory of gases, define Boyle's law, Charles' law, and also Avogadro's law. We know this law as ABC laws, Avogadro, Boyle, and Charles, and also sketch and interpret graph for Boyle's law and also Charles' law. We will also define Dalton gas. So this one, okay, 3 state of matter: solid, liquid, and gases. Okay, properties of gases. Okay, so yang ini pun dah cover dulu. So shape of the gas, take the shape of the container, volume equal to the volume of container, compressibility can be compressible, flow, miscibility, and also density. So ini yang biasalah. Okay, so this one, kinetic molecular theory of gas. So according to this kinetic molecular theory of gases, or we known as also as KM-P, if all the gas follow the postulate, okay, we say that the gas is ideal gas. Maksudnya gas yang mematuhi kesemua teori gas ini. So we have 4 basic assumption in kinetic molecular theory of gas. The first one is volume of gas molecule are negligible compared to the volume of its container. Okay, this is because when we put gas in a container, okay, we can say that the distance between each gas molecule is far apart. So we can say that there is no gas in the container. So that's why volume of the gas is negligible. Negligible meaning tidak dikira. Okay, the second one, intermolecular force between gas molecule are also negligible. Okay, ini disebabkan because of between each gas molecule. Okay, disebabkan distance yang jauh. So kita katakan there are no intermolecular force. Okay, actually akan ada intermolecular force. Intermolecular force kita dah cover di chapter 4. Antara gas molecule ada intermolecular force tapi sangat lemah, very weak, so we can negligible the intermolecular forces. And collision between gas molecule are perfectly elastic, meaning bila dia berlanggar antara satu sama lain, dia tak akan melekat. So dia akan bounce back, okay, dan bergerak semula. Okay, and the last one, the average kinetic energy of molecule is proportional to the absolute temperature. Maksudnya bila temperature increase, kinetic energy untuk gas molecule pun akan increase. So if all gases obey these 4 basic assumptions, so we can say that the gas are ideal gas. So kita akan interrelate between these four parameter in explaining the physical behavior of gas. So we have N, mole, V, volume, T, temperature, and P, pressure. So we relate 2 parameter and the other 2 parameter will be constant. So relation between relate 2 parameter and the other 2 parameter will be constant. What is meant by pressure? So pressure refer to force exerted on a surface area. So this force is come from the collision of the gas molecule to each other and with the wall of the container. So gas pressure refer specifically to the gas caused by the collision of the gas molecule with the wall of the container. So we will have the SI unit for gas pressure in Pascal, Newton per meter square or kg per meter per second square. So 1 atm will be equal to 760 millimeter mercury equal to 760 torr, 101325 Pascal and also Newton per meter square. So actually yang semua conversion ni, this conversion kita tak perlu hafal because kita akan ada satu table of constant pada muka depan soalan. Kita just tahu untuk convert between atm, meter, mercury and also Newton per meter square. So we go to the first law, Boyle's law. So remember we have 4 parameter: pressure, volume, temperature and mole. So in Boyle's law, it states that at constant temperature and number of mole, the volume of a fixed amount of gas is inversely proportional to the gas pressure. Berkadar sungsang dengan tekanan gas. So V proportional to 1 over P because dia ialah inversely proportional at constant. So kita relate pressure and volume. So ada dua lagi parameter ni dia akan jadi constant. So that's why at constant temperature and number of mole. So when we pull up the volume, so we can say volume is increased. But when volume is increased, pressure will decrease sebab ada ruang yang besar. When we push down the piston, the volume will decrease. So when the volume decrease, there are collision between gas molecule in the container and also collision between gas molecule to the wall of the container. So pressure will increase because of the collision. So this is Boyle's law. Relation between V and P at constant T and N. When we have two conditions, we will have P1 V1 equals to P2 and V2. So actually this is the formula for Boyle's law at two different conditions. For example, we have volume 4 liter. So V1 4 liter, 100 kilo Pascal, P1. And we have second condition, volume expand to 8 liter. So V2 is 8 liter. What is the pressure at that new volume? So meaning we want to calculate for P2. So we use the formula P1 V1 equal to P2 V2. So P2 equal to P1 V1 over V2. So P1 100 kilopascal, V1 4 liter, V2 8 liter. So we calculate for P2. So P2 equal to 50 kilopascal. So this is the graph that represent the relation between pressure and volume. So we say that pressure is inversely proportional to the volume ataupun sama juga volume inversely proportional to the pressure. Meaning bila pressure increase, volume will decrease. So kita nampak dalam ni, when we increase the pressure, daripada 2 liter kepada 4 liter, bila dia 2 liter, pressure-nya ialah 0.6. Bila increase volume, so kita tahu bila volume increase, pressure will decrease. Kita nampak pressure drop to 0.3. So curve ni menunjukkan relation antara pressure dan volume dalam Boyle's law, inversely proportional. Okey, yang ni ialah graf untuk pressure versus 1/V. So kita tahu P 1/V. So dia akan kita dapat proportionality. So pressure is directly proportional to 1/V. And another two graph, V against 1/P. Ini sama macam yang P dengan 1/V tadi, cuma kita tukar sini jadi V, sini jadi 1/P. Ataupun boleh juga tadi macam graf tadi, P versus 1/P. Kita akan dapat proportionality straight line. Okay, and last one, satu lagi graf, PV against P. So ini constant. Okay, second law is about Charles' law. So Charles' law state that at constant, okay, so kita ada P, 4 parameter, P, T, and V. So Charles' law relate between volume and temperature. So bila volume and temperature relate, so dua lagi ni akan constant at constant pressure and also number of mole. So at constant pressure, the volume of the gas expand when heated. So maksudnya bila temperature increase, volume increase. Okay, volume tu meningkat bila bila temperature dipanaskan. And contract when cool. So bila temperature decrease, volume pun decrease. So ini ialah relation dalam Charles' law. So at constant pressure and number of mole, volume of a fixed amount of gas, V, directly proportional to the absolute temperature, T. Okay, because of absolute temperature, meaning T ni mesti in Kelvin, dalam unit Kelvin. So convert lah degree Celsius pergi ke Kelvin. So if we have two condition, 1 and 2, so we have V1 over T1 equal to V2 over T2. So temperature mesti semuanya dalam Kelvin, tukar kepada Kelvin, because dalam definition untuk Charles' law tadi dia define as absolute temperature, meaning temperature dalam Kelvin. So absolute temperature in Kelvin conversionnya daripada degree Celsius kita just tambah 273.15 untuk jadikan dia Kelvin. So ini contoh soalan. So kita ada two condition, T1 24 degree Celsius. Okay, we have V1 4 liter. Okay, and new temperature 58 degree Celsius. Calculate for new volume. So calculate for V2. So we will use formula V1 over T1 equal to V2 over T2. So substitute value V1, okay, convert to V1 4, T1 24 plus 273.15 equal to V2 yang kita nak cari, so 58 plus 273.15. So calculate for V2. So remember yang ni mesti tukar kepada Kelvin. So that's why kita tambah dengan 273.15. So this is the answer. So ini dah actually dalam Kelvin. Okay, 4.46 liter. So relation untuk Charles' law. So kita akan guna graph V versus T in degree Celsius, because kita tahu dia dalam degree Celsius dia akan interpret pada negative 273.15. Okay, so kalau V versus temperature in Kelvin, dia akan intersect pada 0, origin. So, combination of Boyle's and Charles' law. So, tadi kita ada Boyle's law, V inversely proportional to 1 over P. So, untuk Charles' law, V proportional to T. So, ini at constant mole and temperature. So, ini at constant pressure and mole. So, bila kita gabungkan kedua-dua ni, kita akan dapat V proportional to T over P. So, untuk hilangkan proportionality ni, kita akan darabkan dengan satu constant. Okay, pemalar, iaitu kita ambillah pemalar tu sebagai K. So, V equals to K P over P. Kita rearrange, kita akan dapat PV equals to K. Okay, PV over T equals to K. So, this combination we known as combined gas law untuk constant mole, because kita ada relation between P, V and T. So, kita ada 4, ingat lagi kita ada 4 parameter P, V, T dengan N. So, kalau dah relate antara P, V and T, kita ada satu lagi at constant number of mole. Okay, this one ialah Avogadro's law. So, remember kita ada A, B, C, D law. So, A Avogadro's, B Boyle's law, C Charles' law, and the last one D Dalton's law. This law state that at constant temperature and pressure, okay, so this one constant, kita ada 4 parameter kan, P, V, N dengan T. So, pada constant temperature and pressure, so T constant, P constant, so kita relate V dengan N. So, volume of gas is directly proportional to the number of mole. So, V proportional to N. Meaning, bila kita tambah volume of gas, mole of gas pun akan bertambah. Okay, V proportional to N at constant T and P. So, if we have two conditions, 1 and 2, so we will have V1 over N1 equal to V2 over N2. So, this is the example for combination between Boyle's and Charles' law. So, P1 V1 equal to P2 V2. So, we have Boyle's law. And for Charles' law, V1 over T1 equal to V2 over T2. So, kalau kita substitute all the values and calculate for V2. Okay, so untuk soalan ni, kita tak perlu convert millimeter mercury. Kita just gunakan yang sama. So, kalau dia, so this one dia tanya add STP. So, kalau STP, kita understood P2 ialah 1 atm. So, kalau 1 atm, equivalent dengan 760 mm mercury. So, untuk pressure, kita kisah dalam unit apa, tapi mesti kedua-duanya sama. P1 dengan P2. So, yang perlu kita convert yang ini. Temperature, because dalam definition untuk Charles' law, temperature tu mesti dalam absolute temperature. Okay, so kita calculate for V2. So, we have V2 39.5 liter. Okay, and last one here is about Dalton's law. So, Dalton's law refer to law of partial pressure. So, Dalton's law state that total pressure, okay, meaning P total for non-reacting gas, meaning kalau gas tu berlangkar antara satu sama lain, dia tak akan produce gas yang baru. So, dia remain as initial gas yang berlangkar tu. So, the sum of partial pressure exerted by each gas in the mixture. Contohnya kita ada dalam satu bekas, ada gas A, ada gas B, ada gas C. So setiap gas ni akan hasilkan pressure-nya tersendiri. So pressure untuk A kita panggil PA, pressure untuk B PB, pressure untuk C PC. So total pressure mengikut Daltons, P total, pressure yang dihasilkan sama dengan pressure yang diberikan oleh setiap gas. Ini PT, P total equal to PB plus PA plus PC. Okay, this one is example for gas A and B. So at constant temperature and volume, P total, P of the mixture will be equal to the sum of the partial pressure for each gas, meaning 1 plus 2 plus 0.5, 3.5 atm.